When we cross the age of 50, something subtle begins to happen inside the body. It's not loud, not dramatic, but deeply influential. The pancreas, a small and often ignored organ, quietly carries the burden of decades. It regulates blood sugar, supports digestion, and acts as a bridge between what we eat and how our cells survive. If you listen carefully to the science and to the body itself, you realize that aging well is not about fighting time, but about supporting the systems that time has slowly worn down. As the body moves beyond 50, leafy green vegetables begin to play a more meaningful role than most people realize. From a scientific perspective, these greens interact directly with how the pancreas manages stress, glucose, and inflammation. Spinach, kale, Swiss chard, and similar plants are rich in magnesium, a mineral that quietly supports insulin signaling inside cells. With age, insulin resistance increases not because the pancreas suddenly fails, but because cells slowly lose their responsiveness. Magnesium helps reopen that communication pathway, allowing insulin to do its work with less force and less strain on pancreatic tissue. These greens are also dense in chlorophyll and polyphenols, compounds that reduce oxidative stress at the cellular level. Oxidative stress is one of the hidden accelerators of pancreatic aging, gradually damaging beta cells that produce insulin. By neutralizing free radicals, leafy greens act like a protective environment rather than a direct treatment, which is often how the body prefers to heal. There is also an important digestive dimension. Leafy greens contain soluble and insoluble fiber that slows glucose absorption in the intestine. This means the pancreas does not have to respond urgently to sharp rises in blood sugar. Over time, fewer glucose spikes translate into less hormonal exhaustion. Research increasingly shows that chronic low-grade inflammation interferes with pancreatic efficiency, and leafy greens naturally lower inflammatory markers through their antioxidant profile. On a deeper level, these vegetables influence the gut microbiome, feeding beneficial bacteria that produce short-chain fatty acids. These molecules send metabolic signals that improve insulin sensitivity and reduce pancreatic workload. What is remarkable is how this entire chain reaction begins with something as simple as a handful of greens on a plate, illustrating that biological balance is often restored through quiet, repetitive support rather than dramatic intervention, allowing the pancreas to function in a state closer to its original rhythm. As the years pass, the cells of the pancreas become increasingly sensitive to damage caused by excess glucose and oxidative stress, and this is where berries quietly reshape the internal environment. Blueberries, strawberries, blackberries, and raspberries are rich in natural pigments known as anthocyanins, compounds that give these fruits their deep colors and their protective biological influence. These molecules are not simply antioxidants in a general sense. They specifically reduce inflammatory signaling that interferes with insulin production. Pancreatic beta cells are uniquely vulnerable because they have limited internal defense systems against oxidative damage. When blood sugar remains elevated for long periods, these cells absorb the stress and slowly lose efficiency. Berries help by neutralizing reactive molecules before they disrupt cellular machinery, allowing insulin production to remain steady rather than strained. There is also a powerful effect on blood sugar regulation itself. Unlike refined sugars, berries deliver sweetness packaged with fiber, water, and plant compounds that slow digestion. This results in a gradual rise in glucose rather than a sharp spike, giving the pancreas time to respond without urgency. Scientific observations show improved insulin sensitivity in individuals who regularly consume berries, not because the pancreas is forced to work harder, but because the body becomes more cooperative at the cellular level. Berries also influence gene expression related to glucose metabolism, subtly encouraging pathways associated with metabolic flexibility. Over time, this reduces the risk of beta cell exhaustion, a process that often unfolds silently over decades. Beyond chemistry, berries represent an important lesson in scale. Something small, consumed regularly, can have a cumulative protective effect on an organ that determines metabolic stability. The pancreas does not require dramatic stimulation to function well. It requires consistency and protection. By offering steady antioxidant support and gentle glucose regulation, berries help preserve the delicate balance between insulin demand and insulin supply, allowing pancreatic function to age with resilience rather than decline. Whole grains take on a different meaning after 50, especially when viewed through the lens of pancreatic health rather than calorie counting. From a biological standpoint, the pancreas is less stressed by how much carbohydrate we eat and more affected by how quickly that carbohydrate enters the bloodstream. Whole grains such as oats, barley, and brown rice are structured in a way that slows digestion. Their intact fiber matrix acts like a natural regulator, delaying glucose absorption and preventing sudden blood sugar surges. Each avoided spike represents a moment of relief for the pancreas, a reduction in the need for rapid insulin release that, over time, can exhaust beta cells. Aging does not remove the pancreas's ability to produce insulin, but it reduces its tolerance for repeated metabolic emergencies. Fiber within whole grains plays a deeper role than most people appreciate. Soluble fiber forms a gel-like substance in the gut, physically slowing nutrient absorption, while insoluble fiber improves intestinal transit and microbial diversity. This matters because gut bacteria convert fiber into short-chain fatty acids, molecules that communicate directly with metabolic organs. These signals improve insulin sensitivity in muscles and liver tissue, indirectly reducing the pancreas's workload. It is a reminder that the pancreas does not operate in isolation. It responds to signals coming from across the digestive system. Scientific research increasingly frames this as a network rather than a single organ function. Whole grains also provide B vitamins and trace minerals that support energy metabolism within pancreatic cells themselves. These nutrients help maintain mitochondrial efficiency, allowing cells to produce insulin with less internal stress. When refined grains replace whole grains, the pancreas faces faster glucose delivery with fewer protective nutrients, accelerating functional decline. Choosing whole grains becomes less about restriction and more about rhythm, creating a slower, steadier metabolic environment. Over time, this steady pace allows pancreatic function to align with the body's natural aging process rather than fighting against it, preserving balance through gradual, cooperative nourishment. With advancing age, the internal environment of the body subtly shifts toward stiffness and low-grade inflammation, and the pancreas feels this change more than most organs. Healthy fats begin to matter not as calories but as biological signals. Fats from olives, nuts, seeds, and avocados integrate directly into cell membranes, including those of pancreatic and insulin-responsive cells. These membranes are not static walls. They are dynamic surfaces that must remain flexible for receptors to respond properly. When membranes lose fluidity, insulin signaling weakens, forcing the pancreas to compensate by producing more insulin for the same effect. Unsaturated fats help restore softness at this microscopic level, improving communication and easing pancreatic demand. There is also a regulatory effect on inflammation. Chronic inflammation disrupts insulin pathways and increases resistance in muscle and liver cells, indirectly burdening the pancreas. Healthy fats reduce inflammatory messengers and support the production of protective molecules that calm immune activity. This creates a quieter metabolic environment where insulin can function efficiently. Digestion itself changes in response to these fats. Meals that include healthy fats slow the movement of food through the stomach and intestines, leading to a gradual release of glucose into the bloodstream. This slower rhythm allows the pancreas to release insulin steadily rather than in sharp bursts, preserving beta cell resilience over time. Within pancreatic cells, fat-soluble antioxidants from olive oil and nuts help defend against oxidative stress. These compounds embed themselves in cellular structures, protecting them from damage caused by fluctuating blood sugar. Aging does not suddenly damage the pancreas. It accumulates small stresses that gradually reduce efficiency. Healthy fats reduce the intensity of those stresses by stabilizing both structure and signaling. What emerges from this science is a principle of care rather than control. By choosing fats that support flexibility and calm, the pancreas is allowed to age with cooperation rather than conflict, maintaining its role as a steady regulator rather than a reactive survivor. Legumes take on a quiet but powerful role in pancreatic health as the body moves beyond 50. Lentils, chickpeas, beans, and peas deliver a rare combination of plant protein, complex carbohydrates, and soluble fiber that works in harmony rather than competition. From a metabolic perspective, this balance is essential. Protein supports tissue repair and enzymatic function, while fiber slows the digestion of carbohydrates, preventing rapid increases in blood glucose. For the pancreas, this means fewer urgent demands for insulin and a more predictable workload. Over time, predictability becomes a form of protection, allowing beta cells to function without constant overstimulation. The fiber in legumes also plays a critical role in shaping the gut environment. As fiber is fermented by beneficial gut bacteria, short-chain fatty acids are produced, which influence insulin sensitivity in distant tissues such as muscle and liver. When these tissues respond efficiently to insulin, the pancreas does not need to compensate by increasing output. This indirect support is one of the most fascinating aspects of human biology, where an organ benefits not from direct stimulation but from improved cooperation across systems. Legumes also have a naturally low glycemic impact, meaning they release glucose slowly and steadily, aligning well with the aging pancreas's reduced tolerance for sharp metabolic shifts. Minerals such as magnesium, potassium, and iron found in legumes further support cellular metabolism and oxygen delivery, both of which are essential for insulin production. Unlike refined protein sources, legumes do not introduce metabolic stress through saturated fats or rapid sugar release. Instead, they offer nourishment that matches the body's changing pace. Over years, diets rich in legumes are associated with improved glucose regulation and reduced risk of pancreatic fatigue. What stands out is how these foods encourage stability rather than stimulation, teaching the body to operate within a calm metabolic range where the pancreas can maintain balance and strength through steady, thoughtful nourishment.